10 environment, 10 people. 10 environment, 10 people.
Hello everybody, and I most welcome you all to the second part of the presentation, which is the thesis and project presentation. And second time, so this time let me try to make it verify and transparent all data. I most welcome you all the teachers, and I will really appreciate it to tell you to appreciate and welcome my dear guide coordinator Ruben sir, and also my guide for this retrofitting in evaluation and retrofitting of existing buildings, Nishant sir. So, you know better, my topic is about the retrofitting and evaluation of existing RCC buildings. So, in this presentation, I'm going to cover the following objectives. To say that what a retrofitting is, first we may shortly define what a retrofitting is. A retrofitting is initial constructions occupants. For example, or we can say the initial construction which is manufactured, if we are going to change the occupants of that, it's called a retrofitting. And also, adapting a system to a new purposes is called a retrofitting. We can say a new technology features to add to the old construction companies, it's called a retrofitting. Or improving the performance of a building is called a retrofitting. And also, we can say that changes in a construction and the other occupants of the structure, members of the structure, to install a new elements, members, that is called a retrofitting. A short definition, a retrofit, we can say a building is very vulnerable to the earthquake or a natural disaster which will affect the building, existing RCC buildings. So here we can say it will limit the significance of a building. So we will need a retrofitting. Also, a knowledge of a seismic hazards and fulfillment requirement. So for these things, we are going to implement a retrofitting. The scope of my work is that this is clear that no owner, if a building is affected through seismic loads, no owner will allow and give a permission to renew or destroy the existing building. So therefore, the scope of retrofitting is more important to retrofit that and withstand that building through the methodology of retrofitting, to withstand it and to complete the significant requirements that the owner of the building has. So in objectives that we are going to have, what we are going to gain in doing our retrofitting is to promote the design deficiencies. Whatever a structure has the deficiencies, through a retrofitting we are going to complete that. Also, we can protect the occupants of the structure. Some structure will be failure. They may face with some difficulties, deficiencies. We may protect that through retrofitting. Structure survivability, and also a public lives to and also to give a structure ductility, stiffness, and also we can say the strength, to strengthen the older structures is called a retrofitting. And we have here all about the retrofitting. We have heard about that. What we are going to, how we are going to retrofit. We are going to study some study cases of retrofitting and how to do that. For example, for electrical forces, for existing electrical forces, that is earthquake, wind, blast, anything, we can resist elements. We can have elements, steel elements, and also for resisting load, roofs, and vertical load resistance for floor and. Okay, and the second one is we can say that the jacketing. Anyhow. So we can say that the ductility and column jacketing, we can use all of them. So, and also for a base isolation, we can do that, and also a weld plates, ply. Yes, this is base isolation, plywood, and also existing lateral loads. We can do that. And also, so in second case, we can have that for retrofitting a prefabricated reinforced concretes. We can do it. So also we can steel stirrups, rest. These literature review. Many people have decided. Many people have written about retrofitting. And what a retrofitting is, how to retrofit. Methodology we can have. Sorry. Methodology, we are going to have all all the elements, all the ways and methodologies, methods and modifications of retrofitting, we are going to follow them. Few of them I am going to mention that how a damping and a base isolation retrofitting. Damping and base isolation is also one kind of retrofitting. So here I'm confining URM, non-reinforcement masonry using RCC tiles. For that we are using RCC tiles. Few cements. Some cracks, some buildings, some slabs, if we have retrofitting needed, we can use a few slabs. Shortcrete is a technique of retrofitting. Example, here what I have done in a STAT Pro program, according to the Pankaj Agarwal book, I have taken all the data. The data is mentioned here. I have taken all the data and I have designed that, tried to design that building. So, what I have done, so for the first time I have did it only a frame of structure of a building which is G plus and ground plus third floor or fourth floor building. I have designed it on the data I have mentioned here. So what I have designed it in STAT Pro. The length and the height of every floor is 3.5 and the length is 2.5 meter. So here I have designed it with only structure without infill walls. It means infill wall is itself a retrofitting technique. So let's design it and see the deflection and the stresses about that. So this is the structure of that. This is the 3D without infill walls, masonry walls. So these are the deflection that I have written in report. I have given all the details, the plus and minus, negative and positive, all stresses I have gotten. This is the whole structure. As we know that seismic is going to apply on a building in a x-axis. So therefore, the deflection on the building of the effect of seismic will be occur on the x-axis. This is the detail, all the detail that we have gotten for beam and columns. So it cannot see that from in everyone we have just from 1 to 10 we have the deflection. This is the foundation results, whatever is gotten. So this is again, I have the second example, I have designed this, I have filled all my structure with infill walls. With infill walls, again I designed it, this is the 3D for that, and this is the deflection for that. So this is the result on that time. For the first time when we designed that book, we designed that structure, it was from all different column and beams, it was from 1 to 10 centimeter the deflection. Here it is 0. So also this is the stresses in beams. This is the shear force, the beam shear forces of beam and columns. This is the negative and positive stresses. This shows the direction of the earthquake that I applied on the building, the direction and also the moment and shear diagram. This is also, so whenever I get all the detail, whatever I have detailed, I have given this is the cross section for that, and I have the reinforcement of that. So this is for one column. Every column and every beam are different reinforcement or maybe deflection. So I have just taken one beam and then taken the example of that, and one column and taken the example of that. So the result is that that retrofitting technique, instead of this, all of the techniques that I have mentioned before, that global retrofitting modification and local of that. So 10 of 10, 20 modification. We can retrofit a building by 12 ways. So infill wall, which I have designed in STAT Pro, this is also a retrofitting technique. Infill wall is that's also. So it means that while adding an infill wall to a structure, negative and positive stresses are less. It means from 0 centimeter to 1 centimeter. And while we are not having the retrofitting, so it is 1 to 10. So at last we are going to say that retrofitting techniques, desired performance, attaining a desired performance, we are getting the design, whatever the owner, whatever those people that they want to have their main objectives, we are going to give him and we are going to make that. For conclusion, we are going to design the building for a better possible while using the retrofitting materials in the best way. This is the reference.